5 probability and counting rules. So now we have learned the fundamental counting rules, the permutation rule, the combination rule. It is possible to compute the probability of outcomes of many experiments. Okay, scheduling worker. Suppose a manager supervises 16 women. Okay, so there is 16 women and 12 men. Each shift needs 8 people. So find the probability that exactly the 3 women selected to the shift. So the probability for the need a 3 women, but the total people needed 8. So which means the other 5 people need to be a man. Okay. So in order to find that, okay, so we have to put it's a probability, okay? So we have to put whatever the people we needed it and divide by over the total, right? So which means they need 8 people, but from the total people from here, so 16 plus 12 is going to be 28 people, right? So 28. But from the 8 people, need to be 3 people from the woman. So woman's 16 times, and then the men's 5 from the 12. Okay, and then you can use a calculator, right? So make sure this is put the parentheses, okay? And then I got 0.1427. All right, the probability that the no woman are selected to work the shift, which means 0 woman, and then which means everybody should be a man. So same idea, totals of 8 people from the 28, but 16, but you don't pick any person from the woman parts, but you need to pick everybody from the men's parts. So compute this together, you got 0.002. Oh, one more 0.0002. Sorry about that. And C, probably that all of the people selected to work the shifts are the woman. So everybody's woman this time. So 8 women, which means 0 men. So you got from 8 people from the 28, but everybody coming from the woman, but men you pick 0, which is compute this one, you got 0.0041. For the D, find the probability that at least one woman, okay? At least woman means from the eight people, it could be a 1 woman or 2 women or 3 or 4, 5, 6, all the way to 8 women. So because of that, easier way to find it is probably of the at least one woman. Easier way is you just put the 1 minus P of none of the woman. Okay, so 1 minus, well, we already have a probability for the none of the woman. So probability of the none of the woman is actually right here, right? So this is what you need to use. So it's going to be 0.0002. And then you got 0.9998. That's a probability. All right, next one. Sequence of the home color. There are 5 houses on a cul-de-sac in a day that restricted the neighborhood. It is a time for all of the houses to be painted. The homeowner association has approved of 3 colors, which is a beige and blue and the yellow as the 3 colors. So how many different color sequences might be chosen to paint the house? So there are the 5 houses. Then each house has 5 choices. Oh, the 3 choices. Sorry about that. 3 color choose. So multiply them all together. You got the 3 to the 5th, which is 243 ways. But B, what is the probability that all 5 houses would at random select the same color? So what if they have all same color? So 1, 2, 3, 4, 5 houses. So what if they have beige, 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 and beige, or blue, 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 or yellow, 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 isn't it? So there's a 1, 2, 3 way, right? So that means it's going to be the 3 over 243 ways, which is 1 over 81. About probability is 0.0123. All right, let's look at the next example. Decorating colors. Decorator is selecting colors for the den wall, the sofa, and accent chair. She can choose from the 10 colors from the walls, 5 colors for sofa, and 3 colors for the accent chair. So how many ways that she can choose the color? So she has the wall, and then the sofa, and then the accent chair, isn't it? So the as a wall, there's 10 different colors you can choose. And then for the wall, sofa, 5 colors, and accent chairs are 3. So multiply, it's going to be 150 ways. But B, what is the probability that if the colors are random selected and she chooses probably for the color for the C form, green wall, and yellow sofa, and turquoise accent chair. So which means this already been said, isn't it? So she need to choose there's a 10 color, but she choose one, and she choose one, and she choose one for the accent chair, right? So the probably will be the 1 time 1 time 1 is 1 over of the 150. Okay, which is the small size of 0.0067. Alright, go to the next one, example 4. So selecting the seminar attendees. In a company with 9 executives, of which 4 are women. So 9 executives, they have 4 women and 5 men. 3 are selected to attend the management seminar. So find the probability that all 3 selected will be a woman. So which means probability of the all 3 women, which means a 0 man, isn't it? So same thing. So how many? 9 people choosing 3, but all of the women from the 4. But so one woman can go, right? Can then 5 men, but 0 selections, okay? So it's gonna be the 0.0476. Find the probability that all 3 selected were men, which means probably for 0 woman, and then the 3 men. So which means choosing 3 people from the 9, but none of the women, but all the selected peoples are the men, okay? So when you do this, you got the 0.1190. And C, find the probability that at least one people, one of the people is a man. So P of the at least one man, right? Which is this is better as well. 1 minus probability of the none of the men. So 1 minus, there's no man, which is only the woman. So I think I can use this probability. So if you subtract it, 0.0476 from 1, you get the 0.9524. That's a probability for C. And then the D, find the probability that the 2 men and 1 woman. Okay? So now 2 men and 1 woman. So choosing 3 from, what am I doing? Choosing 3 from the 9, but there's a 5 men, choose 2 times 1 woman and choose from the 4, right? And then computations, you get 0.4762. For the next one, we're choosing the 2 women and 1 man. So you got 3 people from the 9, and then there are 4 women, choose 2, and choose 1 from the 5 men. And then you get the 0.3571. Not bad at all. Alright, next page. Now, example 5, select the lottery numbers. In a lottery game, owner selects a 3-digit number with a repetition of digits permitted. What is the probability that all the digits the same when the winning number of the selected. Okay, so we need to find how many different digits you can get. So the repetition is allowed, right? So that means you have a 10 choose, another 10 choose, and another 10 choose. So they get the 1,000 ways, okay? But you need to pick all the same number. So what about the same number means? It could be this number. It could be 1 0 0 0 1 1 1 2 2 2 all the way to 9 9 9. So do you see that there are 10 ways? So there are 10 ways from the 1,000 total. So it becomes 1 over 10, 100 becomes 0.01 as a probability. Alright, a person's favorite three-digit number is selected, okay? So there are, but a person's just a favorite number, which could be unique number, right? So there's only the one way, right? Yeah, it's not one, but one way, right? So it will be the 1 out of 1,000, which is 0.001 ways. That's a probability, okay? Alright, let's go to the next page. Okay, gift basket contents. Okay, so it should be the T. The gift basket department at a local upscale grocery store has a pre-made gift basket containing the following the combination in stock. Okay, so the coffee mug candy, the cookies mug and candy, and coffee and tea. So I want to try to get the sum first, okay? So how many totals of the basket has of coffee? So as a total of the coffee, which is 43 coffees, 43 basket has a coffees, and then the 34 basket, sorry, 34 basket has the teas, and then totals are the 77 baskets. And also the cookies, there are 32 basket has the cookies, and mug 23 basket has a mugs, and then there's a 22 basket has a candies. So in A, one basket is chosen at a random and contain the coffee or candy, okay? So this is the addition rules. So in order to learn the addition rules, we're gonna do probability of the coffee or candy. So, which is we have to find the probability of the coffee, probability of the candy. But there's some basket has a coffee and candy which we count twice, okay? So coffee and candy. So as a coffee probably, so this is a coffee. So these are the coffees, right? So 43, right? So there are 43 basket has a coffee out of the 77. And then candy also has candies are this way, right? So 22. 22 basket has candies. But as you notice, when I actually adding the coffees and candies, I'm adding the 10 twice. So I need to subtract one of the 10. And then I got 55 over 77, which is 5 over 7, come out as 0.7143. And then B, if one basket is chosen at a random, it contains a tea, and given it contains a mug, okay? So this is actually the conditional probability. So in order to find that, which is the conditional probability, means you have to have B over A, right? So which is, you got P, A, and B, and then over P of A. So in this time, B is actually the T, and then A is a mug. All right, so the P of A and B is actually the A and B. So the T and mugs, the T and mug is T and mug, right? So 10. So it's a 10 over 77. And then the mug, which is a 23, right? So 23 over 77. So if you simplify, it becomes 10 over 23, which is 0.4348. Alright, C. In one basket is chosen at random, and it contains a tea and cookie. So tea and cookie. So what's a tea and cookie? Tea and cookie. So there are 12, right? So 12, so probably for the tea and cookie. So this is actually the potable, right? So which means 12 out of 77. So come out as 0.1558. All right, D. The three baskets are chosen at random if and then not replaced. All of the basket contains a mugs. Okay, so we are looking for the probability. So you need to find you need to choose a three basket, but the all of the basket contains a mug. So we have to see how many basket has a mug. So there are 23. The basket has a mug, right? So 23 out of 77. But now the it's not going to be replaced back. Okay, so we have to have a 76. Now there are 22 basket left. From the 75, there's a 21 basket left. So multiply, you get the 0.0242. E, if the three baskets chosen at random, not replaced, none of the contain the mug. So none of the contain the mug, which means you actually find out as, okay, so 23 basket has a mug, right? So subtract from the 77, which is 54 basket doesn't have a mug, right? And then same thing, 76, now 53, because you're choosing the three basket. 75, 52. Come out as 0.3391. Okay, if the three baskets are chosen at random and then not replaced, at least one contain mug. All right, so which means this one is probability for at least one contain mug. The same as 1 minus probability of none of mug. So 1 minus, is there any probability to say that the none of the mug, which is the 0.3391, right? So you subtract it. 0.3391 from 1, you get 0.6609. Okay, all right, that'll be all. Thank you for listening.